None of the problems individually are very hard. There's just a whole bunch of them. All right, so number one, find the remainder. What do we do if we have to find the remainder?
-2, long division. Or synthetic division.
So I'll do some division. You don't have to do synthetic, but it sure is easier. So I'll do synthetic division. And all I'm doing is finding the remainder. So 4, -8, 5, -2, what goes in the box? -2, right? Drop the 4 straight down, so here we go. Well, I don't know if I did my arithmetic right. I got -76 as my remainder. Is that okay with everybody? Number 2, there are several questions on the exam that involve the y-intercept. Regardless of the way the equation looks, the kind of equation you have, you find the y-intercept by letting x be 0, period. So I'll put 0 in there. Oh, this next one's going to be a little tougher. So let's go ahead and figure this one out. If I let x be 0, what's 0.8 to the 0th? 1. So I have 14 over 1 plus 3, which is 14 fourths or 7 halves. So the y-intercept is 7 halves. Now the next one, B, still same directions, find the y-intercept. How did you tell me we were going to find a y-intercept? Always, 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 every time. How do we find a y-intercept? We let x be 0. So if we let x be 0, x is 0, then that's going to give me a t value of 3 halves. But I need a y value. I need the y-intercept. So now what am I going to do? Plug in 3 halves right here. So my y-intercept is 6.5 or 13 halves. 6.5 or 13 halves. To find a y-intercept, no matter what kind of equation you have, you let x be 0. Always. Okay? So C is the same thing. So if I let x be 0, what is my y-intercept? Wait, this is a multiply problem. These are multiply, these are factors. So it's going to be 9 times -2. Isn't it -18? All right, number 3. What's happening here? What are we doing here? Exactly. It says find f of x minus 1. Guys, you've worked with functions for years. What does f of mean? When we say find f of something, isn't that just to plug it in? So I'm going to plug in x minus 1. So 3x minus 1 squared plus 9x minus 1 minus 2. Right? Now, we got to simplify that. Be careful. PEMDAS, exponents first, that's a FOIL. That is a FOIL, x minus 1, x minus 1. So we're going to FOIL that out. Now, I can do that in my head because I'm ancient and I do this for a living and I've done it 17 billion times. If you can't do it in your head, that's fine. Just over to the side, FOIL, x minus 1 times x minus 1. Then distribute and collect like terms. And hopefully, we get 3x squared plus 3x minus 8. If I did everything right. Did I make a mistake? Is that okay? Huh? All right, find the vertex. This is a parabola. Everybody should recognize that. It's a parabola. How do we find the vertex? You got a couple of options. One is easy. What's the easiest way? Negative b over 2a. So for our problem, that will be positive 6 over 6, 1, x equals 1. Vertex is a point though, so I'm not done. I have the x coordinate as 1. How do I find the y coordinate? Plug it back in. So that'll be 3 minus 6 plus 1. I got negative 2. So my vertex is 1, negative 2. Remember, the whole purpose of review is to jog your memory so you know what to study. So if you have forgotten negative b over 2a, put a star by that. Spend some time with it. All right, solve. What do you do with this? It's a quadratic, so if it factors, we'll go ahead and factor it, but I don't think it factors. So I'm gonna have to use the quadratic formula. Do we all know the quadratic formula?
Negative b
Yeah.
plus or minus something.
Okay, we better know all the somethings, because we need to know the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. If you have forgotten the quadratic formula, would you please study that so you are ready for that when we take our exam. So x equals 3 plus or minus, all right, the square root of what? Negative 31. And since it's a negative, we'll go ahead and pull out the I. And that's it. Nothing cancels, reduces, nothing. So that is it.
Is there gonna be like a calculator part and
Yes.
then like a
Yes.
non-calculator? Okay.
Yes. We'll talk more about that during our formal exam period, but yes, yeah. And this is all no calculator. I have on the paper here, I have starred the ones that use a calculator. So on this particular sheet, there's only 2. On the other sheet, there's more than that. All right, write as a single logarithm. Write as a single logarithm. So that's fresh in our minds. We're going to just squeeze everything together and write 1 log. Any thoughts on that? ln 7 to ln cube minus ln c. We're going to write ln one thing. What's going to go in there? Katie?
Would it be 7 times 2 squared, q squared over c?
That's exactly what it is. So let's talk about that. Make sure everybody's got it. First of all, a number out in front of a logarithm represents an exponent. So that's how she got q squared. Why did she multiply the 7 and the q squared? Because they're added. And then this one was subtracted, so she divided by it. That's it. That is it. Solve. Loop-de-loop. Boys and girls, log equals number. That's always a loop-de-loop situation. So 4 squared equals x plus 5. So 16 equals x plus 5. It looks to me like x equals 11. Find the polynomial whose roots are 3 and 2i. First of all, you can't have just 2i. You must also have negative 2i, because complex imaginary roots come in pairs. They always come with their conjugate. If the answer, you've got this equation, you worked it out, and you got x equals 3, what was the factor that made x equal to 3? What was the factor that gave that answer? X minus 3? And then similarly, x minus 2i and x plus 2i. Would you agree that these factors would give you those answers?
Yes.
So multiply all this together, and that's your problem. That's the original problem. I would always start with the I ones first, because they will cancel out, a bunch will cancel out because they're conjugates. So x squared plus 2ix minus 2ix minus 4i squared. What do you do with a minus 4i squared plus 4? And then we still have to times it by the x minus 3. So, another FOIL, and there's your answer. There is your polynomial. Whoops, 9 should be crossed off. All right, everybody keeping up? Trying to get through as much as I can here. Number 10 is a calculator problem. How do we solve this? Yep, we're going to ln both sides. And when we do that, all we have left over here is 3x plus 4 equals ln 11. So go ahead and solve that. See if you come up with the same answer I do. Or I'll see if I can come up with the same answer you do. Doesn't tell me how to round, so I'll just go to the 10,000. I got negative 0.5340.
Yep.
So what I typed in my calculator was ln 11. I knew I had to subtract 4 and then divide by 3, because I'm trying to get x by itself, right? List the possible rational roots. We call them PRRs. They're possible rational roots. Factors of 2 over factors of 3. Last over first. So plus or minus 2 and 1 over 3 and 1. Now I'm going to list those. So I need every possible combination. So 2 over 1 and 1 over 1, that's easy. And then 2 over 3 and 1 over 3. There's my list. Every combination of these over these.
If you know if this solves it.
You have to do it, this one just says list the possible rational roots. If it did say that, let's say that was part A, and then B is find the roots, then we would take these numbers and start dividing and trying to get a 0, right? How long will it take 123 to grow into 567 if the growth constant is 11.2% per day? Okay? Which formula? Kurt? I'll give you these formulas. Probably haven't memorized them now, but I'll give them to you. So what goes where? Let's see. We want to start with 123 and end up with 567. This growth constant they gave us a percent, so change it. 112. If they give it to you as a decimal, that's fine. If they give it to you as a percent, you gotta change it into a decimal. First step, divide. Now it looks like one we already did. What are we gonna do now? ln both sides. You get 13.64 days. And again, I'm rounding randomly because I didn't put any directions on here. 13. Consider the square root function. What is its domain, range, zeros, intercepts, increasing, decreasing, asymptotes, bounded? So, in other words, a function analysis of the square root function. You are dead in the water if you don't remember what the square root function looks like. What's it look like? Airdrop for me, square root function. It's the one that starts at the origin and does that. Miss Ford, do I need to remember my BFFs? Yes. Yes. Okay, now, first question, domain. What's the domain of this guy? 0 to infinity. Doesn't the domain is x, doesn't it start at the origin and then go that way forever? There is a dot at the origin, so that's a bracket. All right, range. What's the range of this guy?
0.
Same thing, isn't it? Going up forever. Zeros. Now, zeros are x-intercepts.
0.
So the zeros are 0, one of them. This is the 0 right there. That is also the y-intercept, isn't it? Isn't it where we cross the y-axis?
Yeah.
So the x-intercept and the y-intercept are the same point for this particular function. Would you say this is increasing or decreasing? Increasing. As you draw it, your pencil just keeps going up. Does it have any asymptotes? No. No. Is it bounded anywhere, above or below? Remember, oh wait, you can be bounded above or below or both. Is this one bounded above? No. But it is bounded below. It has a floor. It's bounded below at y equals 0. This is the floor. It doesn't go lower than that point. Wait, there's number 15 on the front. We said we finished 15 on the front. All right, so find the inverse of this function. Anybody remember how to do that? Find the inverse of that function. Meg,
You gotta flip flop the x and the y.
yep, flip flop the x and the y, and then simply
Solve the y.
solve for y. That's it. So we're gonna times by x, add 1, and divide by 2. And there is your inverse. Everybody remember that, those steps? Switch the variables, solve for y. Very, very good. All right, 16 and 18 are the same, so I probably won't do both. Let's just do 16.
This one,
Yeah,
for the number 15, is that the same thing as the plus a half?
yep, it sure is. Yep. Yep, that can be, you can put them both over 2 and make 3x plus 1/2. Yep, perfect. All right, write the equation of this curve. There's a lot going on in this picture. Where do I start? Where do I start? And I don't,
Find out the zeros.
fine, guys, so the zeros are right there staring at me, so she says we're gonna build some factors. And the factors we're gonna build, every x-intercept gets a factor. So x plus 3, x plus 1, x minus 2. That has got to be step 1. That's the foundation of your equation. Okay? Now what? No, we're not gonna multiply. Yeah, you gotta pay attention. What's happening here and here and here? That matters in your equation. Now, what's happening here? Straight through, so that means this guy doesn't get an exponent, or just a 1. Here, though, these two, we are bouncing, so those are going to be squares. Right? Now, we are good to go, except there's this coefficient out in front that controls what? That controls 2 things. What does it control? Whether you're upside down or right side up, right? Which direction you come from, and how high these hills and valleys are. I know I have to contain the point 1, 10. That does not go here. Only x-intercepts go here. That is the point I plug in. Do you remember that, guys? That is the point that's going to help me figure out what my n is, what my leading coefficient is. So I'll put 10 in for y and 1 in for x. So I have 4, 1 plus 1 is 2 squared, and another 4, another 1. I got 5 8s. Did anybody else get that? So my answer, go back and put 5 8s right here, and that's the answer to the question. Now, we're not gonna do 18 right now unless later on you want to. 18, would you agree, is exactly exactly the same situation? Okay, let's look at 17. Projectile motion. The height of a ball above the ground in feet, t seconds after it's thrown, is given by this. Find the maximum height. When does it reach the maximum height? Okay, this is a really easy problem if you recognize what shape is that equation. That's a parabola. Opening. So if we want to know anything about the highest point, the maximum point, don't we just want to find the vertex? And we've already talked about that. How do you find the vertex of an equation that's written in that form? Negative b over 2a. So this time it's tx, I don't care. Negative b over 2a. I got 2. So this is 2 comma something. And how do we find the something? So plug in 2. So negative 16 times 4 is negative 64. Plus 128 plus 2. I got 66, but double check that. Yeah. So now answer the questions. Find the maximum height. What is the maximum height? 66 feet. There's 2 parts to the vertex. One of them represents x, or t, and one of them represents y, or height. So how high does it go? 66 feet. When does it reach its high point?
2 seconds.
2 seconds. All right. Now the last two questions are duplicates of that. What I'd like to do, I mean, if you want to do another one of those, we can. I'd like you to take a look at the review, though. Some of these were included on the mini review, some of them aren't. So see if, as you look through, if you don't mind, I want to do number 20 because I've told you since the beginning, the box problem is an exam question and it has several pieces, so it's worth a lot. So let's do number 20 on the review is the box problem. Okay, we can do repeat problems if you want. I don't really care what we do. I just want it to be something you want to do. But I want to do the box problem because we need to ace this thing. It will be a calculator problem. It has a star next to it. So we have a box being made out of a piece of paper that's 30 by 40. And we haven't done this for a while, but you remember we cut the corners out and fold up the flaps, right? Remember, that's how we build these things. And we want to know, the unknown is, how big the corners are we cutting out? Write an equation for the volume of the box. Okay? Jake?
40 minus 2x times 30 minus 2x. And is it just like x or something?
Just x. Because volume is length times width times height, so there have to be 3 things multiplied to give you volume. The original length of the paper was 40, but we cut off these x's. and 30, and we cut off those x's. And then when you fold up the flaps, isn't x the height of the box? That's how big the piece is getting folded up. That's your volume. Okay, guys, you're going to have a box problem on your exam. The paper probably isn't going to be 40 by 30. It's probably going to be something like 25 by 16. I'm totally making that up. If it's 25 by 16, what's our volume? 25 minus 2x, 16 minus 2x times x. Nobody should miss the equation. These are minuses. You're subtracting the x, you're cutting the x off. Okay, now, I'm gonna skip to question F. So this is A. I'm gonna skip to F because that is normally the next question that's asked. What is the domain of this function? In other words, x has to be between what two numbers? Who remembers what two numbers? Lauren?
0 and 15.
She says 0, and what was the other one? 15. Now, as an interval, that would be 0 to 15. I wrote it this way so you could physically see x is between those two. Now, is she right? Is it 0 to 15? Yes, because this is always 0. If you're cutting out with your scissors, doesn't it have to be something positive? So it's got to be bigger than 0, and then where did the 15 come from? Half the smallest dimension. So this paper was 30, smallest, so 15. Very good. Now, next question, I'm going to sketch this on my calculator. This is x min, and this is x max. If you don't set your window appropriately, you could come up with answers that don't make sense in the problem. So limit yourself to x min and max. Jake, did you have your hand up for something?
Yeah, would the range be it with the 40, so if x 0 is less than x greater than 100? So like, how do you know when to use the 30 versus the 40 for the domain?
Always the smallest. Always the smallest. Think about it, Jake. If you said I could let x be 20,
Yeah,
can I cut 20 off? No, you have to use the smallest dimension. All right, so x, I'm going to graph on my calculator. So x min is 0, x max is 15. Now y min, remember in your equation, y is the volume. Doesn't y also have to be bigger than 0? Doesn't the volume have to be positive? So y min is going to be 0. Y max is actually what we're searching for. So we're just going to make up a big number. I'll start with 1,000. I don't know. Let's see. Then I'm going to type in my equation. Get rid of these other equations here. Okay, so 40 minus 2x, 30 minus 2x, and x. And I'm going to go ahead and graph. Oh shoot. So when it says sketch the function, you're going to have your calculator for this problem. So we're going to sketch it on our calculator. This is what I saw using the window that I had you set up. What's wrong with that? My y isn't big enough. So I think I'll go back and maybe make it 3,000. Ooh, that's barely. I'm gonna go back and make it 3,500. So I just played around with it until I saw what I wanted to see. So part B says sketch the equation. There it is. It's always going to be some kind of a hill. What is the maximum volume of the box? So maximum would imply that point right there. So I'm gonna go ahead and find that point. So second calc max. By the way, don't be thinking negative b over 2a. This equation is not quadratic, right? Yeah, so there's no vertex. That may look like a parabola, but it's not. All right, so second calc max. And I got, for my maximum, 5.657, comma, 3032.3025. Anybody else get that? Okay, so now we gotta answer the question. Question C, what is the maximum volume of the box? So just like with your parabola, there's two parts to the maximum point. The first part is x and the second part is y, of course. What does x stand for in our equation? The size of the corners. What does y stand for in our equation? The volume. So what is the maximum volume? 3032.303 cubic inches. That's the volume of the box. Right there. What question would 5.657 answer? What size are the corners that we cut out? Huh? Okay. D. What size would the corners be to have a box with a volume of 2,000? All right. Clearly our maximum is more than 2,000, right? But I could cut out other corners and have a volume of 2,000. So what am I gonna do? I'm gonna go back to my calculator and I'm gonna put in another equation. Leave that one in, but put in y equals 2,000. And then hit graph. Did a line come shooting through your curve? These are the places where the volume is 2,000. How do we find those points on our calculator? Second calc intersect. And we have to do them separately. So I got, for this one, I got an x value of 2.192. Obviously the y is 2,000. And for that second one, I got, oh, I got 10. Is that right? Okay. So question D, what size corners would be cut out to have a box with a volume of 2,000? Well, we could cut out 2.192 inch corners, or we could cut out 10 inch corners. So think about geometrically what's happening. If the corners you cut out were this, wouldn't you have a big, shallow box? But if you cut out this size corners, you would have a kind of a small base, but a very tall box. And both of them have a volume of 2,000. Last question. I told you this one has a lot of parts. What size would the corners be to have a box with a volume of at least 2,000? What does at least 2,000 mean?
Anything above.
2,000 or bigger?
Yeah.
So everything above Peter, wouldn't that just be this right here?
Yeah.
So everything between 2.192 and 10 would have a volume bigger than 2,000. Good? Okay, well, I wanted to do that when I picked that one, so now you pick another one. You pick one now. There's two sides to this thing, there's a lot of problems here. So what do you think? 11, solve, it looks like a little absolute value there, it's kind of hard to read. Okay, what are you gonna do first? Now, there's different ways to solve this, but no matter how you're solving it, you've gotta do something first. What are you gonna do? Add the 7. You gotta get that absolute value by itself. Now, remember when we did these, I tried my darndest to get you to approach it like a calculus student, but most of you didn't. Most of you went back to what you learned before, which is fine, it'll work, it'll work. So what do you think of when you look at this to solve it? It makes no difference. I don't care how you solve it, just figure it out. Kara?
Like there's two different equations.
She said, I'm breaking it apart. I'm gonna say 4x minus 3 equals 8. Or 4x minus 3 equals negative 8. This will work, guys. It's fine. So 4x equals 11 and x equals 11 fourths. Or 4x equals negative 5 and x equals negative 5 fourths. So here are the answers to the problem. Sydney, you okay with that? All right. Anybody else see anything, or I'll just randomly pick? We got 10 more minutes. I'm not gonna waste a second. Lauren? 23. Yeah, this one requires you to remember a few things. So you may need to take note of this. So we've got this curve, and we want to know what it has symmetry about. And the special symmetries are x-axis, y-axis, origin, and identity. Now, Lauren, one way you can approach this problem is to just sketch it. Now, it's a no calculator problem, so you're gonna have to be able to sketch it on your own, but I think you can sketch this. What does that look like? That's a parabola vertex at the origin. What does putting a minus 4 on the end of it do? Drop down 4. So a sketch of this would look like that. Would everybody agree? Now, if you're going to have symmetry about the x-axis, let's say, that means if you took this parabola and folded it across the x-axis, it would duplicate itself. It would mirror itself. It would land on itself. If I fold this across the x-axis, I get something totally different, don't I? But what if I fold it across the y-axis? It has symmetry, doesn't it? It has symmetry about the y-axis. It does not have symmetry about the origin. Envision folding this way. And it does not have symmetry across the identity line. Obviously, no, it doesn't. So, if you are comfortable and able to graph your curve, you can tell just by imagining. There are tests of symmetry though, for x-axis, y-axis, origin, and identity. In case you either can't graph whatever you've been given, or you can't tell from your graph, you can always do the official tests. To do the official tests, you make a change in the equation and then see if it matches the original. So here's what I mean. For the x-axis, you change the sign on y. Is that equation, if I change the sign on y, do I end up with the same equation that I started with? No. So there's no symmetry there. Okay? Now, what about y-axis? Well, to do y-axis, you change the sign on x. Wait a second. Is that going to simplify to be the same equation that I started with? So that does have symmetry, which is what we discovered through the graph, but this is like the algebra way to do it. Origin, you change the sign on both of them. When you clean that up, that is not the same as the equation I started with. Would you agree? So that's a no. And then for the identity, you switch the variables. So just make this an x and this a y. And clearly that is not the same equation. So the only one this has symmetry to is the one that we noticed graphically, okay? So here are the official tests. Change the sign on y, change the sign on x, change both, flip variables. And then after you make that change, look at what you ended up with, compare it to what you started with. If they're the same, it's a yes. If they're not, it's a no. All right, good. Mine?
I have a question on the, I know how to find the vertex, but the second part of this house is currently here to
Okay, so let's find the vertex first, because that's going to be a key piece. So what's our vertex? Well, I gotta do negative b over 2. I got negative 1. Is that right?
Yeah.
And now plug that in, so I get 3 minus 6 minus 1, negative 4. Okay, so stop a minute and think. The vertex of the original, y equals x squared, is at the origin. Well, the vertex of this guy is at negative 1, negative 4. So what have we done? We've moved him left 1 and down 4. If I wrote the equation in vertex form, it would look like this. Because I go left 1 and down 4, and there's a 3 coefficient out in front. So, the changes that have been made to the original, this is the original. We went left 1, down 4, and we have a vertical stretch by a factor of 3. Remember, putting a multiplier in front multiplies your vertical, makes it 3 times as high. Okay, so those are the changes. You went left, down, and vertical stretch. The easiest way to figure that out is go ahead and find the vertex.
What does it mean, the tangent to x-axis again?
Where are you?
Right below 13.
Problem 13?
Yeah.
Okay, so let's look at number 13 real quick. Let's do the whole thing. I'm gonna start with the sketch, because I think we can answer all the questions from the sketch. So looking at number 13, we kind of did this a little bit a minute ago. I'll start by putting on my x-intercepts. So they're at 1, negative 4, and 5. Everybody in agreement? This is problem 13. X-intercepts come from the factors. They are the zeros. They are the dots on the x-axis. Now, let's finish this sketch. How many x's does this problem have altogether? 4. There's 4 x's, aren't there? X to the 4th, if I wrote out them all. What does x to the 4th look like? What does any even look like? Up. So this starts up here. What does it do when it hits at -4? It bounces, connects to here. What does it do there? Goes through, connects to here. There you go. So up, just exactly what we expected. X-intercepts right here. How do we find a y-intercept? I see I have one, I just don't have it labeled. How do I find a y-intercept? Always plug in 0, so -1, 16, -5. I got 80. 0, 80. Where is the graph tangent to the x-axis? Where does it just touch the x-axis? -4, 0. Yep, that's your point of tangency. Remember a tangent in geometry, we talked about them with circles, that was a tangent. Just hit, they whip away, and the sketch is done. So yep, there you go. That's what that means. All right, guys, we got one more day of review. You need to dig through that review material and come up with some questions, okay?